Good day everyone, we are the ALPHACODE RJEA Group 2 from ITC 123 and today we will present our Arduino Uno project number 6, the alarm. And our member are Rainmark Amoja, Alsha Abdul Ghaffar, Emmanuel Veloso, and Janrick Valle. Here is the component part of alarm. First, let's talk about the main component, the Arduino board. An Arduino board is a microcontroller platform used for building interactive electronic projects. It allows us to easily connect sensors, outputs, and write code that control the behavior of our project. For this activity, the Arduino is the brain of our alarm system. Next, the buzzer. A buzzer is an audio signaling device that produces a buzzing or beeping sound. It is commonly used for alarm, timer, and even for giving feedback in our project. The buzzer serves as the alarm sound output. And lastly, we have the jumper wires. These are electrical wires with pins or connectors in both ends. Used to make temporary circuit connections without soldering, they make it easier for us to connect the Arduino to the buzzer in our circuit. Here is our circuit diagram. It shows the Arduino connected to the buzzer using jumper wires. The setup is simple but effective in creating an alarm system. Our project also uses a simple Arduino code. The code tells the Arduino when to activate the buzzer, producing the alarm sound. Without the code, the components alone cannot function as an alarm. Here is a clear line-by-line explanation of your Arduino alarm. Float scene val, a global floating point variable to hold the scene value, range about -1.0 to +1.0. And the end tone val, a global integer variable to hold the buzzer frequency inherent. For void setup, run once at power up or reset. Pin mode 8 output sets digital pin 8 as an output, not strictly required for tone, but harmless and clear. Void loop runs forever. For int x equals 0, x less than 180, x plus plus, repeat the inner code for x equals 0.179 and 180 step. This cover half a sine wave to 0 degrees to 180 degrees, which make the pitch rise and then fall back. Convert scene function angle to radians. For the scene, computes the sine of the angle. X asterisk 3.1412 divide 180 converts degrees to radians using the pi equals 3.1412. Works, but you'll get slightly better accuracy using Arduino's built-in pi constant or radian x. Scene val equals sin radian x. To calculate tone frequency based on scene value, tone val equals 200 plus and scene val asterisk 1000 adds a base frequency of 2000 Hz. Because your loop only uses 180 degrees, sine tone val range to 2000 to 3000 and to 2000, each sweep giving a smooth serene like up and down. It generates sound frequency using the scene function value. And for tone 8, tone val generates a square wave at tone val hertz on pin 8. Each call updates the frequency. The tone keep playing until the next tone, call or a future new tone. Delay to pause for 2 milliseconds. Wait 2 milliseconds before moving to the next step. With 180 step x 2 millisecond, 360 ms per sweep, you hear a quick rise and fall about 2.8 times per second. And the for loop and loop, then loop restarts, repeating the sweep continuously. In summary, our Arduino Uno alarm project uses three main components: the Arduino board as the brain, the buzzer as the alarm sound, and the jumper wires to connect everything. This project demonstrates how hardware and code work together to create a simple but useful alarm system. This project shows how simple hardware plus a few lines of Arduino code creates a functional alarm. That's all, thank you.